Hi, Mrs McTaggart here, and in this lesson we're looking at the first lesson in higher for vectors, and in particular we're looking at what's called position vectors. So this is quite an important part actually, because you'll use this little skill all the way throughout the higher vectors chapter. So what I've got just to introduce position vectors is this little diagram here. So we have two vectors, we have A and we have B, and what I'm going to do is I'm just going to label these as little a and little b on the diagram. Now, the vector from 0 to A would literally just be the same as a coordinate of A. It is your directions that you're following from the origin to A. So it would be along 3 up 4. So as a vector, O to A is 3 to 4. Similarly, B can be written the same. It would be along 5 and up 2. So the vector O to B is 5, 2. Now we can clearly see from the picture that the vector A to B is along 2 down 2. So A to B is 2, negative 2. But there is another way to do this and prove it without having an image there all the time. So we're going to do it using alternative pathway vectors. So the two vectors I've got drawn in black, O to A and O to B, are called position vectors. And that's the fancy name given for a vector in relation to the origin. Now, not all vectors can be drawn like this or have an image handy, so there must be another way to get the vector A to B a bit quicker. So if I was to use alternative pathways, to get to A to B I would do this, and I would follow my line. So I'd go against vector A, and then I would go along vector B. And the way to write this would be as negative A plus B. But as mathematicians don't like that, it looks a lot nicer if we reverse it round and do B minus A. So you might notice the connection with the letters. It's basically going to be, you start with your end point and take away your starting point. So if you're going from A to B, you do the destination or end point B, take away A. So here it is written a wee bit shorter, or in a wee bit that would probably be better to look in your notes. So the shorthand, whenever you see a vector from A to B, you can write that as B minus A, and then we'll put in the numbers. Now the numbers we had a second ago for these vectors, if I put these in, B was along 5 up 2, and A was along 3 up 4. And if you do that take away sum, 5 take away 3 is 2. And 2 take away 4 is negative 2. And then that 2 negative 2 is what we had just from the image before. So what we're going to do is we're going to use this rule now and see it in actual context. So we have given you the coordinates of P and Q. So what we're trying to find is the components of P to Q. So here is P, here is Q. We're going in this direction. So we start by writing P to Q equals, and it's Q take away P. And then we just plug in our numbers. So Q is 4, 1, and P is 3, 5. And if we subtract them, 4 take away 3 is 1, and 1 take away 5 is negative 4. And that's all there is to it. So that's you told me what the vector P to Q is. Now remember, my little drawing over here was just a sketch. It would actually probably look a lot more like this if I was drawing it accurately, P to Q. But I just always think to like to draw a little sketch. The same rule applies if it's in 3D. So this time we're asked for the component form of D to E. So we've got it from an image. Again, it's just a sketch, it might not be accurate. So D to E will be the same as E take away D. So it's always your end point, take away your start point. So plug in the vectors. We're going to 5, 0, minus 4. Take away negative 3, negative 5 and 6. Now as always, be very careful with your integer work and your double negatives. 5 minus minus 3 is 5 plus 3, so 8. 0 minus minus 5 is 0 plus 5, so 5. And minus 4 minus 6 is minus 10. So that would be vector D to E in component form. And that's it. That's all there is really to position vectors. So hope that's helped. Go off and have a wee practice. Thanks for watching.